Hello everyone. This video will go over the solutions to homework number 6 for ME 3270 or manufacturing processes. So let's jump right to it. So the first problem we have is problem number 16, which states, estimate the time of contact and average force when a fluorine atom strikes a silicone surface with a velocity of 3 millimeters per second. Hint. See equations 911 and 913. To begin, let's identify these equations 911 and 913. So in doing so, we see the following. First off, the first equation we have is the time of contact. So TO is equal to 5R over CO, and that is multiplied by C of O over V, and that has a power to the 1/5. Next up, the other equation is our average force equation, and that is equal to 2mv over TO. So we see that F is dependent on TO, so therefore we must solve for our time of contact first. But when we take a look at our time of contact formula or equation, we have a couple of variables that aren't defined. These variables are going to come from a handy table that have the properties of silicone and fluoride. So let's go ahead and identify those. So to begin, we have our density of silicone, and that is 2,330 kilograms per meter cube. Modulus of elasticity, represented by E, that is 190 gigapascal, or 190 times 10 to the 9 pascals. Our velocity was defined in this problem as well, which is V. You'll notice in the solution manual it uses 0.001 or 1 meter per second. In our case, it's 0.003. Oops, sorry about that. And that's meter per second. We'll also need our radius of fluorine, and that is 0.119 nanometer, or times 10 to the negative 9 meters. And it looks like these are all the variables we need. Let me take a quick count. Yes. So to begin, what does C of O equal to? So C of O is the wave speed, and the wave speed is equal to the following. So C of O, wave speed, is equal to the square root of our elastic modulus over the density. So plugging in those numbers, we get the following. So 190 times 10 to the 9 over 2,330. Working that math out, we get a wave speed of 9,030 meter per second. Now we're ready to plug into the contact formula, the formula on the left right here above. So let's go ahead and do that. So T of naught is equal to 5 times R, which is the radius of fluorine, which is 0.119 times 10 to the negative 9 meters. That's going to be over C of O, or the wave speed, which is 9,030. That's going to be multiplied by CO once again, so 9,030. Once again, velocity is 0.003. Keep in mind that the solution manual plugs in 0.001, but based on our problem statement, it's 0.003, and that is raised to the 1/5. So working this math out, we obtain a value of TO that is equal to a value of T naught that is equal to 1.30 times 10 to the negative 12. Sorry about that. Update. Times 10 to the negative 12 second. And that is the solution to the first part of this problem. Now we want to find the average force. So recall that that formula is equal to 2mv over T naught. Plugging straight into this formula, we get 2 multiplied by 3.54 times 10 to the negative 26. Once again, our velocity is 0.003, and that's going to be over the t we just found, so 1.30 times 10 to the negative 12. Working out this math right here, we obtain a value of 1.634 times 10 to the negative 16 newtons. And that is the solution to problem 16 for homework number 6.